Hello guys, and welcome to a new series of videos in which I will be showcasing different techniques to model and design vehicles in CAD, model and design different details for said vehicles, and also how to design those parts with 3D printing in mind. In the first video, I will try to showcase a bit more advanced technique which I use to model complex panels on vehicles, and in this case I will be showcasing it on a model of Eurocopter EC665. I've been working on this model for some time now. It will be 2.5-meter remote control helicopter where the fuselage and all of the parts will be 3D printable. Now pretty much all of the parts are ready. I'm just finishing some of the detailing on the main fuselage section. So this video, panels and panel lines. Now if you're doing any hard surface modeling, whether it's aircraft, tanks, or mecha and so on, in this subject matter you will frequently have a lot of panel and panel lines. Now if in most cases this can be quite simple, like we have here, where it's a planar surface, and I already modeled a couple of panels here, which are actually overlapping panels. And how to do it is very simple. You generally create a sketch and extrude the solid to solid in the shape of the panel, and then merge it, combine it with the main model. Now obviously things get more interesting if you start looking at more complex geometry. So for example, here we have the hump around the exhaust and infrared suppression system of the helicopter. And what I did here, I modeled a panel around the turbine exhaust. A couple of interesting things here. First of all, the surface itself where the panel resides, it's across multiple faces, and each of those faces was lofted. So the faces are tangent, but it's still multiple faces. And what I actually wanted to do here is to have a panel that goes along the exhaust pipe, and it's fixed width. So here it's 24 millimeters all across the feature on the surface. So modeling this kind of detail, this is already not as trivial as you would be doing something on a planar face. So I would like to, in this video, showcase how we can do it, and we're gonna do it on a different part of the model, which is actually the tail. If I bring up the photo documentation, which I have here, of the tail section, if you're doing any of this kind of modeling, more photos you have, the better. As you can see, we got here a panel that goes along this hump, all across the tail. It's actually multiple panels, but for the sake of this video, let's treat it as a single one. So, but the really interesting thing is this panel actually, it overlaps. It goes from the hump and overlaps on this crease going to the main part of the fuselage. And this is what we want to model. So if I'm gonna look at the geometry, this means we're gonna be creating a panel going along the top section of the tail. But we want to have it overlap here, and have it overlap that it will be a fixed width of also 24 millimeters. Now what is really tricky here is, if you look, it will be going along multiple faces that have been lofted, but as well the crease here, along this crease. But if you're gonna look at the faces along this crease, the angle actually differs. So here it is almost 90 degrees, but as it goes down the crease, the angle between faces, it almost goes to the point where the faces are continuous. So this kind of was a bit of a small challenge. So I did discover a technique I would like to share here. But let's start with the basics first. So if I would want to create a offset, create a panel along a feature that is actually confined in a single face, actually SolidWorks provide a very useful tool for it, which is offset on surface, which allows you to create an offset from the edge within a face. But there's a limitation to that feature. It allows you only to create an offset within a single face. As such, there is no option to create an offset on multiple faces that on the edges that are adjacent to each other. So unfortunately, doing a offset going along this crease over those three faces is not possible. However, there is, as I mentioned, there is a technique. So let's go over that. Generally, when I start designing the panels, what I do is I want to work on a fresh surface, so I will create an offset surface on the faces I want to work with. So I already created another cut tool that outlines the end of the panel. It's also quite helpful to identify which faces I need to offset. I need to actually copy, offset with 0 copy. So the ones that go along the crease and also up, and on the other side it's same story. Yes, I think this is correct. So I'm creating an offset of the surface with offset 0, which creates a copy. And I'm gonna hide the solid bodies here and start working on this. So objective is to create a panel of fixed distance away from the crease. In order to do that, what I normally do is create a tool that will outline this distance, and use that tool to trim out the excess that is further than 24 millimeters. Now, the best way to do that is actually a sweep surface using the circular profile. The idea is I will create a pipe that will have a radius equal to the distance of the panel I want to have away from the crease, and this pipe will be centered along the crease. So the distance I want to do is 24, hence the pipe needs to have a radius 24, so 48 millimeters diameter, and I select the path along the crease. Let's do. So I have a nice preview. Thankfully, SolidWorks managed to create this pipe, and this will be used as a trim tool. Now you can see this is still not useful because this surface goes beyond, hence I need to extend this pipe using the extend surface tool, using the same surface extension type. I don't need to do it on the other side, but for the sake of completion I will do it anyways. So now I have a trim tool. Now, because the model is symmetrical, at least in this regard, I will mirror it to the other side. So mirror tool has been already selected. I'm doing this along the right plane. So now I have two helper tools that I will use to trim the excess that is further than 24 millimeters. So again, surface, trim tool, remove section 1, and then I'm gonna use the second one, trim tool, also remove section. At this point I don't need those helper tools anymore, so I'm gonna delete them. And I'm gonna use the sketch to trim the back side of the panel here. And hooray! Huzzah! I've got a surface that's been trimmed perfectly with this offset being the exact 24 millimeters across the whole crease. So the only thing remaining is now to thicken it. 640. I'm gonna hide this sketch now. And voila! I've got the panel I was looking for. So now let's open the, let's show it with the main model. It is exactly where I want it to be, except a couple of minor details. So potentially here I might want to extend this. To overlap with oh, not possible. Actually, we can fix this in a different way. So let's go back here. Let's hide this again. As we want to have an overlap there, we're gonna extend this section a bit as well, using the same surface model. Here it should be more than 25. This will allow this to blend nicely into the model itself. So let's do a bit of a thicken as well. And now compare it against our model. Yes, so now this will blend nicely into the top section of fuselage. The only thing remaining here, still here we have a bit of sharp edges. Best way to deal with it is just to create fillets. I normally create those fillets after the surface has been thickened. You do not want to create fillets on a sketch. You used to trim such a panel because then the projection of the, especially when you're dealing with complex geometry, the projection of the fillet on from the sketch will not be the same based on the depending on the angle of the geometry it is projected on. So you want to leave it and do the fillets on the thickened geometry, and voila, it looks complete. So fast comparison. Indeed, so this, the only thing remaining now is to create the cuts here, to split this single segment to the multiple panels as in the real model. However, the challenging bit, which was this crease, has been resolved. So hope this will help you and you will find this video helpful. Please leave the comments, please your feedback in the comments, especially if you would like to see more videos covering such a subject matter. So please subscribe, like and comment. Thank you very much.